going to be talking about the difference between factoring trinomials when you just have the x squared plus bx plus c when there's no leading coefficient versus when you factor one that does have a leading coefficient, like a 2x squared or 3 or 6 or 4, or any of those fun numbers. Okay? So first we're going to review what it's like to factor our trinomials without the x squared. All right? So guys, whenever you do this lovely little factoring here, I always like to make my x. Now guys, there are a lot of different ways that you can do this. Some teachers just write the number with the 2. They make like a little T. I like the x because I think it organizes it well for me, okay? And on the top of your x, you put that lovely C value, right? That 24. On the bottom of your x, you put your lovely B value. And you have to find the two numbers that multiply to 24 but add to 11. Anybody want to help me out? 8 and 3. Very good. So guys, this is the beautiful thing. When you do not have a coefficient, a leading coefficient, guys, those are your two factors right there. So you do not have to factor by grouping right here. This gives you your factors of x plus 8 and x plus 3. All right, y'all? Is this ringing any bells? You guys feeling good about this? All right? Now, once we get our answers here, what are a couple different ways that we can check our answers on number 1 here? You could go without the calculator. You can just multiply it out, right? You can say, okay, x times x gives me x squared. X times 3 gives me that 3x. 3x plus 8x is 11x. And 8 times 3 gives me 24. So you could actually do the multiplication. The way that you can check yourself in the lovely calculator is you can type them both into y equals, right? You have x squared plus 11x plus 24. And then we have our x plus 8 and our x plus 3. And it gives us, there's one graph, bam, the second one graphed right on top of it. So they are the exact same curve. You can also check in your table and make sure your table values, your y values, match up perfectly. So guys, those are ways that you can check yourself in your calculator. And also one thing I want you guys to notice is, guys, when you have your factors, you can also easily identify your zeros. My 0 would be -8 and -3, right? It's the opposite of what's inside those factors. Okay? So those are some good little reminders here. All right? So if we are going to factor this lovely guy right here, we want to find the two numbers that multiply to 12 but add up to +8. And so, Sophia, what would those be? Two numbers that multiply to 12 and add to 8. So if you do not know, a great way, the little trick for how to figure that out is you can go back to your y equals and you can type in 12 divided by your x. And when you go to your table, you are given a list of whole number pairs here. Okay, all of these numbers multiply to give you 12. And we want to find two whole numbers that also add up to 8. So yes, we can see that really quickly. That would be 2 and 6. All right, now with these smaller numbers, you could probably see these in your head. But when you start getting big numbers, sometimes I don't know all the factors of 294, and I need a little bit of help with that. And that's okay to use your resources there. So we have 2 and 6. So my two factors would be x plus 2 and x plus 6. Now, question for y'all. Weston, does it matter if I have x plus 6 first or x plus 2 first? No, it does not. So if I write x plus 2 times x plus 6 and you wrote x plus 6 times x plus 2, it doesn't matter because these are two numbers that are being multiplied by each other, or two factors that are being multiplied by each other, and it doesn't matter which one comes first. Okay? So that is a quick and easy way to factor. So what I would like you guys to do now is we are going to take a look at number 3. So we want to find two numbers that multiply to negative 15, but add up to a positive 2. And that gives us what two numbers multiply to negative 15, but add to a positive 2? Ian, go for it. 5 and negative 3. Very good, because negative 15 is negative. One of our numbers had to be negative. And so 5 times negative 3 gives us that negative 15, but 5 plus negative 3 gives us the positive 2. So that right here gives us x plus 5 times x minus 3. Do y'all feel good about this so far? And like I said, you can always check your answers. So what I want you guys to do is I want you guys to go ahead and do numbers 4 and 5 on your own, and then we will check our answers here in just a moment. Guys, so for numbers 4 and numbers 5, we had x minus 9 and x plus 2. And we had x minus 6 and x minus 7. Do y'all feel good about that? Any questions for me how we got those numbers? Y'all feel good? Okay, now guys, so when you see something with just an x squared, not 2x squared, not 3x squared, nothing in front, then you know all you got to do is find those two numbers. So in summary, what I want us to talk about, guys, is that all you have to do is find the two numbers that multiply to C but add to B. Right? We want to find the two numbers that multiply to our C but add to our B. Do y'all feel good about that? And then what I want you guys to notice is what's our pattern here? If C is positive, what is true about both numbers? Okay, well, here they're both positive or they're both negative. So guys, if C is positive, both numbers are both positive or both negative. Do y'all feel good about that? So if C is positive, they're either both positive or they're both negative. How can you decide if it's positive or negative? Looking at your B value. If your B value is positive, they're both positive. If B value is negative, they're both negative. All right? But guys, if your C is negative, what is true about that? Oh, one number is negative and one number is positive. Do y'all feel good about that? So, if C is negative, one number is negative and one number is positive. How do you guys decide which one is the positive number and which one is the negative number? You look at your B. If your B is negative, the bigger number is negative. If B is positive, the bigger number is positive. Does that make sense? Do y'all feel good about that? Okay? So this is just a quick little review about how to factor. You have your lovely trinomials here. Okay? Awesome. Next, we are going to go over here and we are going to factor trinomials that have a coefficient. And guys, this is when you will use your factoring by grouping. Okay? We almost start the exact same way, but what is the difference about the number that we put on top of our x here? You have to do A times C. Your A times your C here. So on the top, now we have a 10. And on the bottom, now we have an 11. Do you guys feel good about that? So guys, what two numbers multiply to 10 but add to 11? 10 and 1. Excellent job. So guys, now when you have that leading coefficient, you must factor by grouping. So I'm going to say 2x squared plus 10x. And then I personally like to give myself some space, plus 1x plus 5. All right? And then we go here, and 2x squared plus 10x. What can we factor out of that? 2x, and we are left with x plus 5. Out of 1x and 5, we can really only factor out a 1, but that's okay because we are left with x plus 5. So what are my two factors in this case, y'all? 2x plus 1 times x plus 5. All right? One mistake that is easily made, all right, is you can look at this and you say, oh, my two factors are x plus 5 and x plus 5. But no, your two factors are this 2x plus 1 times your x plus 5. Do y'all feel good about that? Maybe? Yes, maybe? All right? And once again, how can we check ourselves? Typing them both in the calculator. We can go here and we can type in 2x squared plus 11x plus 5. And then, guys, if you accidentally were thinking to yourself, oh, it's x plus 5 times x plus 5, well, guys, check it out. If I did x plus 5 times x plus 5, that is not going to be the same graph at all. But if I go in here and I said 2x plus 1 and times x plus 5, that will give me the same graph. We got one here, and bam, it graphed right on top of it. And my tables are exactly the same, so we know it's a good line, or a good one there. All right, then we'll go here to our next one, 6x squared plus 7x minus 5. So guys, when I make my x, what goes on the top of my x here? Negative 30. And what goes on the bottom of my x? 7. All right, so what two numbers multiply to negative 30 but add to 7? Eric?
Negative 3 and 10.
Negative 3 and 10. Does it matter which one comes first, y'all?
No.
It does not. In my last class, I did 10 first and negative 3 second. Doesn't matter. Okay, so then we're going to go here, 6x squared minus 3x plus 10x minus 5. So that gives us 3x, and we are left with x minus 2. And then I'm going to pull out a 2 here, and we are left with, uh-oh, what happened? What did I do wrong? Oh, we're not pulling out a 2. What are we pulling out, y'all? A 5. My bad. So 10x divided by 5 gives me 2x. Geez, man, I'm struggling today, aren't I? That's a 2x minus 1, isn't it? And 2x minus 1. It's Friday, y'all. I was like, what is happening? So my two factors are 3x plus 5 and 2x minus 1. Remember, you should be getting, the remainder should be the same on both of them, right? That 2x minus 1. All right, any questions for me on number 7? All right, I want you guys to go ahead and do number 8 on your own. I already have, awesome. Do number 8 on your own, and then we'll go over it in. All right, guys, so hopefully you can see on number 8, the correct answer is, there we go. It is 3x minus 2 and times x minus 2. All right, guys, any questions for me on this? All right, so for our summary here, what is the biggest difference between factoring trinomials that have a leading coefficient and ones that do not?
You have to multiply the a and the c.
Yes, for this one, you have to find the two numbers that multiply to AC. That's our big difference here. We got to find the ones that multiply to AC and add to B. It always is going to add to that B, but guys, when you have that leading coefficient, it's multiplying to the AC. And then, guys, this is where I recommend always factor by grouping. All right, guys? Any questions for me about factoring so far? Okay, so guys, for the rest of class, these were our notes today. For the rest of class, we are going to be talking about, we're going to be playing a quick little game, and then you guys have your homework. Now, quick reminder, guys, there are, on the back of your page here, I just want to write a couple little things. There are two special cases, right? Two special cases. So, I'm adding this on. Sorry, guys. So, one special case is, guys, if you have, let me get the actual formula chart so you guys can see this here. So, guys, your two special cases are our perfect square trinomials and our difference of squares. Now, guys, we've done a lot of perfect square trinomials, but I don't know if you guys remember our difference of squares. If you guys have a squared minus b squared, this factors into a minus b times a plus b. So, guys, the way that looks for something would be if we had like x squared minus, does anyone want to give me a perfect square? 25. That would factor into x plus 5 times x minus 5.
Sorry for the interruption. There was a band shuttle that just arrived. Please let these students into your classroom without counting them absent or tardy. Thank you.
People band.
Thank you. They're just lost in their music, all right? So here we go. And then if we add something like, I don't know, let's do 9x squared minus 121. Are y'all good with that? I'm just making up perfect squares here. So that would be 3x. What do we got here? What's 9x squared minus 121? Well, guys, that would have been 3x squared minus 11, or 3x minus 11, and 3x plus 11. Now, guys, the benefit in doing it this way is, guys, it does save you some time. Okay, if you remember this lovely little difference of perfect squares. Because, guys, here's the deal. You could have factored this one by grouping. All right? You could have factored both of these by grouping. But you would have had to rewrite it as this 9x squared. You got to think minus 0x minus 121. So, guys, you could have factored this by grouping, but a times c, I'm not going to lie, 9 times 121, you're looking at the two factors of negative 1,089. And what of those will add up to 0? Now, guys, those are just big numbers, all right, guys? So it's not that you can't do it. It's just kind of annoying. Does that make sense? So this is where you would go to your calculator and you'd say, okay, negative 1,089 divided by x, second table, and you have to find two numbers that are going to add up to 0. And guys, the two numbers that add up to 0 from 1,089 are going to be all the way down here at 33 and negative 33. So guys, it still works and you can still do it, but it just takes a lot more effort. Does that make sense, y'all? Are you guys kind of tracking? So if you had done this, then you would have said, okay, 9x squared minus 33x plus 33x minus 121. I can take out a 3x, so I get 3x minus 11. I can take out an 11, so I get 3x minus 11. So we have 3x plus 11 and 3x minus 11. Whew! Do you guys see how much easier it is to memorize the pattern? Yes, sir?
So, for whenever 0 is down there,
yes.
Should we just find the square root of the top one?
Yep. So that's a great thing there. Guys, whenever there's a 0 there, you can just find the square root. So because the square root of 1089 is 33. You are exactly right, because they have to be the same number if they're going to add to 0, right? So that's another way to do that as well, which is why it can work that way. So guys, if you can memorize the pattern, it does save you quite a bit of time. Now the other one that we have had a lot of practice with, because we did completing the square, are these lovely ones, where if you have a squared minus 2ab plus b squared, that one is going to give us a minus b squared. And then if you had a squared plus 2ab plus b squared, you have a plus b squared. These are our lovely little perfect square trinomials, correct? If you can recognize the pattern for those perfect square trinomials. Okay? And so I will give you guys a quick example here. So if we have 4x squared, and then let's do minus, I'm going to say plus 9. So that's what, 2 times 3, 6. So it's going to be minus 12x. Is that right? So if we have 4x squared minus 12x plus 9, that would factor into 2x plus, oh, no, not plus 3. What would it be? 2x minus 3 squared. Because of that minus 12x. And then if we had something like 9x squared, let's see here, and then I'm going to pick the last term here because I'm just making them up on the spot. Plus 16, so that's what? Plus 24x. That would be factor into 3x plus 4 squared. Now guys, for these, you can definitely still factor by grouping, but if you can memorize that pattern, it will help you significantly faster. Does that make sense, guys? You guys kind of tracking? So if you can memorize those little patterns for your difference of perfect squares and your perfect square trinomials, it will save you guys a little bit of time. Just a quick review. All right, any questions for me on this stuff here? No? Excellent. All right, so we're going to go ahead and get ready to play a game.